Hey everybody, I'm Chili, and welcome back to tutorial 18 of Beginner C++. Today's lesson, I'm going to be talking about what actually happens when you build a solution. I know in the first video, I told you the compiler goes nom nom nom, but that might not have been 100% accurate. So now I'm going to give you the dirty download. We're going to dig into the guts of the Visual Studio toolchain. So just kick back and watch the show. It's time to teach you about the birds and the bees and the CPPs. But first of all, some facts. Fact, only CPP files are input for the compiler. You might think that H files and CP files are both input into the compiler, but that's not really true. I mean, you could say that, but it's kind of complicated. Like, look at this. Here I've got a simple solution. It's empty, but it only has one header file in that. If I try to build that, it will build fine, regardless of the fact that it's not proper C++ code.
You will never get this. You will never get this. La 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 la.
But if I try to run it, it says no, can't run it. The exe does not exist because you need at least one CPP file. CPP files are the thing that is actually input into the compiler. A solution with no CPP produces no exe. H files are input, but they're input indirectly. Fact. Every CPP file is considered separately. It's like its own island. They say no man is his own island, but every CPP file is its own island. So when you're compiling this CPP file here, the compiler has no knowledge of any of these other files. Fact, there are 3 processing phases when you build a project. The phases are pre-processing, compilation, and linking. Now, pre-processing and compilation are carried out by the compiler, and linking is carried out by a separate program called a linker. All right, now I'm going to talk about the 3 phases. The first phase, pre-processing. What that does is it does a bunch of text processing bullshit on the CPP file before it gets sent to the compiler proper. For example, it includes other text files into the CPP file. Generally, we call those text files H files. So when you see these lines like #include main-window.h, this is a command for the preprocessor to take main-window.h and insert its contents into this point in the CPP file. In fact, the # is generally just a signal that this is going to be a preprocessor command. So anytime you see these #, that's preprocessor bullshit. Preprocessor can also do simple text macros. And I'll show you examples of that later on. It's also responsible for removing the comments from the source code before it gets compiled. You can also use the preprocessor to conditionally remove some text from a source file before it's compiled. So take a look at this here, this if def else end if thing here. This allows you to set some code that can be conditionally excluded from the source file before it's compiled. So right now, this code here, you can see it's rendered a little bit. The text is rendered a little dimmer, and that means that it's not going to be included when this is preprocessed. It's going to be stripped out of the CPP file. Now, the preprocessor is also responsible for some other BS. Maybe I'll talk about it later, maybe I won't. But generally, it's just a dumb text processor for the most part. It doesn't track any sophisticated relationships between the symbols. It doesn't check anything about the C++ language. And the output from the preprocessor, with all the header files included and everything, all the code, the comments stripped out, we can generally call that a translation unit or maybe a module. Different people call it different things. Now, let's take a look at what that looks at, because generally you don't get to see that. You get to see the source files and the headers, and then you get to run the exe, but you don't see the intermediate stuff, but you can if you want to. So let's go right-click on the project here, and we'll go Properties. And here you can set up you can configure a whole bunch of shit about how your solution is built. So remember I said that pre-processing and compiling are both handled by the compiler. So the settings for pre-processing is in the same place as the settings for the compiler. and that's under C, C++. So we go to preprocessor, and we can go here, preprocess to a file. Yes. And this will suppress compilation, so you will not get an exe out of this, but you will get a preprocessed file, a translation unit if you like. So I've just created a simple thing here, a source file, and it includes header.h, and header.h is just what I showed you before. So if we build this, we'll get an error. We cannot open file blah blah blah.object. That's because we haven't actually compiled. We just preprocessed. So now let's take a look at the output. So it's debug and source.i. And this is the output after the preprocessor is run. So you can see here. Let me see here. Here we have where the header was included, and so it just jammed the pragma once, and the suckit compiler, you will never get this, into the source.cpp, and it also removed that comment, no longer in here. You can also define a macro with the preprocessor directive #define. So this is defining a macro called square, and it takes one macro parameter and it just outputs that parameter and then the asterisk and then that parameter again. So if we do this and we run our preprocessor, what we get is this right here, return 5 * 5. And it's just a dumb text processor. So if I just put in here something retarded like cock and balls and then ran that through the preprocessor, it would just return cock and balls * cock and balls. So it's not smart at all. It doesn't understand what it's doing. It just takes whatever text is in here and it copies it into the places in here with all the other stuff. But it's useful very rarely, but you should always prefer functions because it's a dumb macro and it can't do any kind of error checking. So avoid macros whenever possible. After the preprocessor has had its way with the CPP file, it's all done its bullshit. The result of that is going to get output into the compiler proper, I guess you could say. And the compiler is going to take that source code and it's going to turn it into machine code, basically into assembly language code, and it's going to put all the functions of the machine code into a file, and that file is called an object file. Now I'm going to remove all the bullshit macro from here, and I'm going to remove this stuff from here, and let me go into my properties and we're going to turn off preprocess to a file. So we're just going to do normal preprocessing. Apply that, and what else? Now, what we can do is the compiler will output an object file, but it's not going to be human readable. It's going to be machine code. But what we can do is we can tell the compiler to output something called a listing, an assembly listing, which is a human readable form of the machine instructions. So down here in output files, we can go up to here. We can go assembly only listing, assembly with machine code, assembly with source code, and assembly, machine code, and source. So let's do everything. I don't know how garbagey that's going to look, but we'll give it a shot. And we're just going to compile this. There's not going to be much meat on these gym mats, but we'll see.
There's very little meat in these gym mats.
So yeah, we'll build that. And then if we go into here, debug, now we have COD. I guess it's COD. It's weird. And here you have all of what this stuff compiles into. It's not much. Most of it is just initialization stuff and then cleanup stuff here. Now, if we add a little operation here for the compiler to compile, now we see we get a little bit more meat on those bones. So we got a imul instruction here. That's multiplication. So that's going to be this one. Increment is going to be this thing here. Add is going to be this. And compare is going to be this guy here. And then the jump here, jump, if less than, is going to be for the loop. So these instructions here represent the loop. And if you see, this is the address of the instruction, and this is the actual machine code of the instruction. So this multiplication here is 3 bytes for that instruction. This increment is 1 byte, and that process is carried out for every CPP file in your solution, producing one object file. And those object files, they basically just contain a collection of machine code instructions for each function. So it includes a collection of instructions in every object file here. There's other stuff, but it's mostly just functions. So now you got an ass ton of object files, but you don't want object files, right? You want one exe that you can run. So what do you got to do? Well, you take those object files and you jam them into something called a linker. And what the linker does is it's going to stick all those object files together in one exe. Now that's not the only thing it does. It also links all of the function calls to their destinations, hence the name linker, right? Because remember, every CPP file is its own island. So if you call a function from this CPP file that exists in this CPP file, this compiler isn't going to know how to get from here to here because it doesn't know about this CPP file. So that job is left up to the linker. When it comes time to link the objects together, the linker looks in this object file, it sees a function call, and it checks to see if there is a corresponding function in any of the objects. And if there is one, it puts the address of that function into this function call. And it's not just about linking up function calls between objects. A lot of the times you're going to call functions from, the standard library or from the Windows library or whatever. And the linker is also going to link those function calls to the function calls from the library. So take a look at this code here. I'm calling the Windows function to display a message box. Dick and balls, and here you go. Now, what happens if, let's see, I go into properties, and we're going to go into the linker here. Now, there's input, and here is a list of libraries that we're linking to. And all a library is it's just a collection of object files jammed together for convenience. So, now the function that we're calling the message box function, I believe it's in user32.lib. Now, if I go in here and I delete all of these additional dependencies, so now we're not going to link to any libraries except for the C runtime library. And then I try to build this motherfucker. We're going to get a problem here, unresolved external symbol. So here we get an error. It's not a compiler error, it's a linker error. And it's unresolved external symbol because it can't find the function that this is trying to link to. It checked everything it has to link to, and it finds nothing. Now, we could add a function call to the standard library function exit. And if we do that, we will see that builds fine. There's no problem about the exit call. But what we could do is we could go one step further. We could tell it to ignore all default libraries, and that will tell it to ignore everything, including the C runtime library. And if we try to build with that, then we get a bunch of different ones, including can't find exit. Future Chili here, just with one more thing to add. So we got this message box. We're calling it "We're failing hard." Now, we could have a couple of ways we could fix this. We could do the thing. We could go into the settings here, and in the input, in the dependencies, we could write in here user32.lib, and that would work. If I build it, you'll see no problem. But there's another thing we could do, and that is, I'm gonna just delete this from here again. Delete that, and build. Okay, we're failing hard. What we can do is we can use a preprocessor directive to set a linker setting. So we can go pragma comment, and I never remember the syntax for this, but I think it's lib and then in double quotes the name of the library. So user32.lib. And if I build that, works fine. So what you can do is, instead of setting the linker settings inside of here, you can set them by putting a pragma into a source file. And this is good because now if you take this source file and you put it source code and you put it in another project, you don't have to change the project settings for the dependency, because it's automatically in the source code. And if you look in the framework in a file like graphics.cpp, this graphics is interfacing with Direct3D. And here we have a line, pragma comment library d3d11.lib. These days, this is the preferred way of linking to external libraries. You add them with a pragma. So yeah, that's the linker. Its main job is just to jam all the objects together with anything useful from the libraries, and then link all the function calls up. All right, now to wrap things up here, I want to give you guys some practical examples that are going to help you really understand why things are the way they are in C++. Why do we have header files and so forth? So here is what we're going to start from. Very simple example here. We've got a main and it calls the function f, and the function f just returns 69. So we build that, builds fine. It should, run fine. Yeah, it runs. Okay. Now, what happens if we move this function down to the bottom and then we try to build this? We get a failure. F identifier not found. And this is due to the way that C and C++ compile their source files. It is going to run through here and it's going to get up to this function f, but it doesn't know what the fuck f is because it hasn't reached that yet. This is down here. And in C++, you can't call a function until you have it properly declared. So we do what's called prototyping or forward declaration in this case. Because the function appears afterwards, we have to forward declare it. So we give its prototype. We go, well, there's this function and it's called f. It returns an int. It takes nothing. That's what it is. And once you do that, builds fine and it'll run fine. Now, let's take it a step further. Let's add another source file to the project. So I've added f.cpp, and now I'm going to copy this function into here. And it's the same deal, right? This builds fine. If I remove the prototype, it's not going to build because it doesn't know what the fuck it is. So in this situation, it's going to build two object files, f.object and main.object. And then the linker will link up the function call from main to f. Now, what happens if the names, they don't match up? Or even if the name matches up, but the function is a little different? So now we'll have a function that takes a parameter in here. But here we're prototyping it as a function that doesn't take a parameter. When we build that, you'll see it compiles fine, but the linker complains because the linker can't find an f that takes an int. It can only find, or an f that takes nothing. It can only find one that takes an int, so it's no good. And if we change the prototype here, yeah, it's fine, and build it, now the compiler will complain because, well, okay, so this does not match this, right? The prototype doesn't match the function call. And if we, make everything match, then of course it's going to build and it'll be fine. Success. All right, let's go one level deeper now. I've added a file g.cpp, and that contains a function g that calls f, all right? And then in main, we're going to call both f and g. So what do we got to do here? Well, first of all, we got to forward declare f in here. So int f into x. And in main.cpp, we got to forward declare both of those. So let me just copy this, paste it in here, and put that in there. So now they're both forward declared. Everyone should be happy. Build that, and it works. Now let's say I change f. I change it from int x to float x. Now what's going to happen if I build this? Well, build solution, I'm going to get a failure because now what was expected by these guys isn't matching the actual function in f.cpp. So if I change this, now I'm going to have to go into here and I have to change float here, and I'm going to have to go into here and I have to change float here in both of these. And if I do that, then it will succeed. Now that's fine, but imagine now f isn't being called just by 2 other files. Maybe it's being called by 200 other files. Do you really want to go in now and every time you change a function, change the prototype in every file that uses that function? No, that is a goddamn pain in the ass. So what you would want to do is something like this. Maybe you'd want to go project, add new item, create something called a header file. We'll just call it a header file. And and then in your header file, type your prototype out. So if I got f, let's go to 1 here. There we go. So I'll just put my prototype in here. And then instead of typing out the prototype at the top of every file, I'm just going to type include f.h. And that'll include the prototype for that function. And for every other function, in f.cpp. So I'll do f.h here. I'll include f.h in here. And then if I build that, works just fine. And that's basically the reason why we have headers. It's super hard to maintain all these forward declarations. It's way easier if you just have one header file that contains all the forward declarations for the source file. And then you just include that header file anywhere where you want to call functions from the source file. Bloody efficient. And of course, we can do the same for our g.cpp. And it'll look something like this. You got your g.h here, and you include it in here. All right, I've set up another simple situation here that we can learn from. So we've got 2 header files here, f and g, but this time we're defining classes. So we've got class f, which is just an empty class. And then we've got class g, which is a class that contains an f inside of it. Now, because g contains an f, it has to know what f is. So we include f.h inside of g.h. And then in our only source file, main.cpp, we include f, we include g, we create an f, we create a g. So far, so good. Build it, works fine, no problems. Okay, now, here's where it gets interesting. Because remember back in the day, I told you this pragma once, it's important, don't get rid of it or your shit's gonna get wrecked. Well, what happens if we get rid of it? Build that. We get a failure. F class redefinition, note declaration of f. And then here we get G uses undefined class f. So what is this bullshit? We don't understand. We don't know what's going on here. Well, the problem is you can't define the same symbol twice. So what happens here? Let's take it step by step. Include f.h. So we include f.h. This text gets copied into main.cpp. Then we include g.h. So this text gets copied, but this one also includes f.h. So f.h gets copied twice. And there you have your redefinition. If you don't trust good old Chili, you can go to we'll go to main.i, and here you see it. No. You've got class F, and then here you've got class F again, and then you've got class G. So that's no good. And what pragma once does, see if I can find it in my goddamn, there it is. What pragma once does is it says in any translation unit, in any CPP file, only allow this file to be included once. So what we do is we include f.h, and then we go to include g.h. G.h tries to include f.h again, but pragma once cock blocks it, and so f.h is only ever included once. Then we only have one f.h, only one g.h, and everyone is motherfucking happy. All right, let's try one last dumb thing for today. So we've got G, and it contains an embedded F, right? Let's make F also contain an embedded G. So now F is going to include G. G is going to include F. What could go wrong? Build a solution. Failure. My F, unknown, doesn't know what the fuck is going on here. So what is this bullshit? What's happening here? I mean, we included G in here, so it should know, F should know about G, and G should know about F, and everyone should be fucking happy, but they're not. Why not? Well, to make a long story short, I'm going to do the thing. So here's the preprocessor output for main, and what we get is, so we include F, and then F is going to include G, and then here's class G, and then here is class F, and then there you go. So, but the problem is, well, wait a minute, but we included F here. What happened? Well, the problem is because of the original inclusion of F, pragma once prevents F from being included again. Because imagine what would happen if that were possible. I mean, we'd include F, so we'd copy the text of f.h into here, and then F would try to include G, so we'd copy the text of G, but G would try to include F, so we'd copy the text of F, but that would try and include G, and so on and so forth. It's just a bullshit infinite loop of garbage. So what pragma once does is it says, okay, main tried to include F, so we include F. Then F tries to include G, so we include G. G tries to include F, but no, pragma once, you can't do that. You only get one. Cut you off. So now F is not included here, and so G now doesn't know about F. It doesn't know about the class F. So you can't have circular dependency like this. You can't have a header where you include G.h in F.h and F.h in G.h. It just won't fly. No circular dependencies. Now, it is possible to have some kinds of circular reference, but it's a little complicated, and I'm going to deal with it later. But just know that you should not be doing this because it's not going to fly very well. So yeah, that is the general build process for C++. That is where exe babies come from, and that is why we have header files and why we have pragma once. It was a little bit of a different episode this time, but I think this stuff is kind of important to know as well. So there won't be any homework for this one, but be sure to let me know in the comments or, on the Discord or the forum if you have any questions about this stuff, any ideas, and myself or one of the other C++ badasses will be able to give you some knowledge. But that's it for now, and I'll see you soon with some more C++.